Welcome to Summarize Science. Large language models are becoming incredibly powerful, but they usually require massive servers to function. The researchers behind this paper noticed a major problem. These models are simply too big for the memory in a standard laptop or phone. They focused on a specific architecture called Mixture of Experts, which is great for efficiency, but creates a huge storage footprint. To solve this, the team created a system called DyMoE to orchestrate how these models run on smaller hardware. One of their key insights was that not every part of the AI is equally important for every task. They observed that expert importance is actually highly skewed and depends on how deep the layer is in the model. By identifying which parts of the model are heavy hitters, the system can prioritize them for higher accuracy. Meanwhile, less important parts are compressed using a technique called mixed precision quantization. This allows the model to take up much less room in the device's memory without losing its intelligence. The researchers also found that early layers of the AI are very sensitive to a loss of detail. However, as the information moves deeper into the network, it becomes much more resilient to compression. DyMoE uses a depth-aware scheduler to keep the sensitive early layers at high quality while shrinking the deeper ones. This smart allocation ensures the AI still makes sense even when its memory usage is slashed. Another clever trick they used is called look-ahead prefetching. Since loading data from storage is slow, the system tries to guess which experts will be needed next. It begins loading those parts while the current calculation is still happening, essentially multitasking to save time. This effectively masks the waiting time that usually makes AI feel sluggish on hardware with limited bandwidth. The experimental results on real-world edge hardware are quite impressive. DyMoE was able to speed up the time it takes to see the first word by up to 22 times compared to older methods. For the overall speed of generating a full sentence, it achieved a speedup of over 14 times. Crucially, these massive gains were achieved with almost no noticeable drop in the AI's accuracy. To recap, this research proves that bigger computers aren't always the only answer for better AI performance. By being dynamic and prioritizing the right data at the right time, powerful models can finally fit in our pockets. This development paves the way for truly private AI that doesn't need to send your data to the cloud to process it. It could also lead to smarter offline assistants and much more responsive apps on consumer devices. In the future, this technique might allow even more massive models to run on hardware we use every day. The age of high-performance AI on the edge is closer than ever before.